Please confirm whether my screen is visible or not.
Yes, ma'am, it's visible.
Okay. So in the last term, we have discussed about some evolution components, okay, about the evolution of GIS, and after the evolution, we have seen the components of GIS. So there are total 5 components of GIS. Yeah, at my side, it is showing there is some bad network quality. Is there any problem in the audio?
No, ma'am.
Okay. In the last time, we have discussed about the components of GIS, and we have seen that there are total 5 components in GIS. So write down the name of the components in your copy. Write down the name of all 5 components in your notebook. So it is hardware, software, people, data, and infrastructure or organization. Okay. So these are the basic 5 components of GIS. So first one was the hardware. We need, if you talk about the hardware, we need a proper hardware support for running any of the GIS. First is the basic requirement regarding the computer. So you will need a high quality processor, a lot of memory to store the data, a high resolution, good quality screen. Okay. Then keyboard, mouse, printer, plotter. These all are the basic requirement. Apart from that, we need some sort of, if we are going for the surveying, then in that case, we may need some GPS receiver to collect the position. Or there are several handheld devices nowadays that measure the spectral. With the help of the spectrometer, you can measure the spectral signature of that mineral material. So depending upon the type of data collection that is required, there are so many different hardware. Okay, there is audio problem for the other students also.
Yes, ma'am.
Yes, ma'am.
Okay, then wait. Okay, so my audio is okay now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So after the hardware, we have seen the second component was software. Okay. So in the software again, you have seen that diagram, that how there are different steps where we need this software. Suppose you have the data with the help of a GPS receiver. Okay, after that you need to transfer that data from the handheld device to the computer system. For this transfer, you need some software support. Similarly, if you are doing, say, you have done the digitization part, you have started that thing in the laboratory session. So in that case also you are doing the data input, you are performing the digitization. That thing also need a GIS software. Then suppose you want to perform some analysis on that data, on the collected data, on the input data. Again, there is a need of a GIS software. Once you have done the analysis, once you have done the manipulation, you may need to store that data into a database. You may need to show the results as an output. Again, there is a need of software. So there are various categories of softwares that are available. First one is the GIS software. You are working on the QGIS software. It is an open source. Another option is ArcGIS software, which is a proprietary software, and it is a product of ISRI. Then there is a GeoMedia, then there is a GRASS, then there is Ilvis. There are several software that are providing GIS as well as image processing support. So although they are image processing software, still they are providing some functionalities of GIS also. So it depends upon the type of tasks that we need. Usually the ArcGIS software or the QGIS software are self-sufficient when we are doing the GIS operations. But it depends upon the type of task. Many times some of the operations are not available with that particular software. In that case, sometimes we perform the switching. Okay. So apart from the GIS software, we may need some image processing software like ADAS. Okay. So ADAS is again a very popular software. It was by Intergraph initially, and nowadays it is provided or distributed by Hexagon Geospatial. Then you need to store that data. So there is a database requirement. For that database, we have PostgreSQL. Then if we are moving towards the WebGIS, and we will learn about the WebGIS in the next semester, but if we are moving our GIS to the web, which is quite common nowadays, in that case, we again need a different set of software, GIS mapping software, online styling software, and other things. So there is a very rich, diverse availability of GIS software. You must know the name of the GIS software, remote sensing software, image processing software, and WebGIS software. So whichever subject you are studying, whether it is GIS or any other subject, try to go and search about the different types of software that are available for that thing. Okay, so it will increase your practical knowledge. There is one more suggestion from my side. There are some of the magazines that are freely available. So like there is ASPRS, American Society of Photogrammetry and Remote Sensing. They give a magazine called Photogrammetry Engineering, PERS, Photogrammetry Engineering and Remote Sensing. Although this magazine is not freely available, but still there is one or two article of that magazine is freely available. So you can go to the internet and search about this PERS, Photogrammetry Engineering and Remote Sensing, PERS magazine by ASPRS, American Society of Photogrammetry and Remote Sensing. I hope all of you have written on these names in your notebook. PERS by ASPRS. Okay, so go through this magazine if this is available. Apart from that, there are a few other, like there is a magazine called GIS magazine. There is Geospatial Weekly. Write down all these names. So you may get some of the magazines freely available. You just need to subscribe. So what is the plus point of these magazines is that you will get the information of all the things that is recently going on. Although you are getting the information through the lecture session, but it is quite theoretical. But when we read these magazines, we actually get what is going on these days. Okay, like suppose if you want to purchase a new mobile, if you go through the newspaper or if you go through the magazines, you will know what is the latest model of that particular of smartphone and other things. Okay, so here also there is the same thing. If you read the magazine and such type of thing, you will get more knowledge, more information about the products, about the companies. So coming back to the topic, So the components are hardware, software, then there is data. As you know, there are two types of data in GIS. What are these two types of data? Write down in your copy. First one is the spatial data and second one is the attribute data. GIS or working on GIS is like working on data. And if you do not have the correct data, if you do not have the precise data, in that case, the results are not correct. There is a term GIGO, means garbage in, garbage out. So if you fill your database with the garbage, means if you fill your database with the incorrect, inaccurate data set, in that case, whatever analysis you are performing, whether that analysis is correct or not, doesn't matter. It doesn't matter that you are performing the things correctly, but still the output is not going to get correct results. It will have inaccurate results because the input data is not correct. That's why the preparation of data is very important. As mentioned earlier, the GIS database creation is a very long, very time-taking task. So a major part of a GIS project is spent on the database creation. So we need to know about the data. We need to know how to acquire that data, whether we have a budget to acquire that data or not. If we do not have the budget, in that case, what are the other sources through which we can acquire that data? So we have to think, even when we decide any of the topic, we first think about the data and then about the topic. Okay, because whatever you select, the first requirement is data, and whether you have the budget to acquire that data, because the cost of data acquisition is quite high. If you go for high resolution satellite images, some of them, very few of them are freely available. Most of them are proprietary. You need to purchase and the cost of them is very high. Okay. So we need to learn about the data. We need to learn about the database creation and other things. Then the fourth component is people. GIS is a people-centric system. Everywhere, whether it is a GIS creation, whether it is a GIS use, whether it is GIS maintenance, everywhere you will find people who are involved in it. And depending upon the type of user, again, we have a diverse type of GIS. Then the final one is the infrastructure. In some of the book, you will find organization as the fourth component. So it is basically about the infrastructure support that we need in the GIS development. You cannot develop GIS in isolation. Okay, you need certain support from the organization, from the infrastructure to run the GIS project, because it is not something that you are just sit on the table and chair and make the programming and do the things. You need to go on the ground to collect the data and other things. You need to provide the solution to the people. That's why the people and the organization are the component of GIS. Okay, so that's that much we have covered till the last lecture, and now we are coming to a new topic that we need to learn today, and this topic is geodesy. Okay, so write down this term geodesy. So first of all, what is geodesy? As written on the screen, geodesy. So geodesy is the division of science associated with the measurement and portrayal of the Earth. Geodesy is also known as geodetics, and it is concerned with the determination of the shape and size of the Earth as well as its elements. These Earth-based elements include its terrestrial gravity, magnetic field, tide, polar motion, and other things. Okay. So basically, if in a simple words, if I say what is geodesy, so geodesy is all about the measurement of the Earth and the related elements. So there are two terms, geomensuration and surveying. Okay, so when we say geomensuration, it means when we are measuring the earth as a whole, when we are considering for some purpose, when we are considering earth as a whole and we are working at the global level, in that case we go for the geomensuration. Second thing is surveying. When we take a small part of the earth and perform the measurement and other things, then it will call the surveying. So these are the two different terms that are associated with the geodesy, geomensuration and surveying. Okay. Now if we go to the thought that what is the exactly, because in geodesy we learn about the shape and size of the earth. Okay, so if we say about the shape and size of the earth, the question is, what is the shape and size of the earth is? Okay, any thought? Any view about this? What is the shape and size of the earth is? So basically, yeah. Yes, somebody is answering it.
Spheroid.
Spheroid, yes. You know, the shape of the earth, the estimation of the shape of the earth is a very long, have a very long history, and since several years, the people, the scientists, the scholars are trying to give the shape of the earth. Okay, like, you know, in the ancient Greek, there are the different people. If you have learned in your history subject, there is Homer, there is Pythagoras, there is Plato. All these people have tried to give the shape of the earth, like Homer. Okay, so he given the idea that the earth was a large flat disk. So he has given the idea that earth is a flat, it is like a disk. So although we know that the earth is a spheroidal nowadays, but at that time it is a very strange thing, because they used to say, why not people are falling? If earth is a sphere, if it is round shape, then why not people are falling down? So initial estimation of the earth was like a flat disk. Then Pythagoras, the famous mathematician, we all learned Pythagoras theorem. So he has said that earth is like an ideal spherical sphere. So it is ideally round figure. Later on, Plato gave us some educated guess about the earth's circumference as somewhere around 40,000 miles. Then there are other people like Archimedes also given the circumference of the earth. He said it was about 30,000 miles. So there are so many mathematicians, scientists, scholars, and other people who are trying to estimate all these things. So over the time, people have tried to give the shape and size of the earth, and at that time this thing was also big because they do not have any satellite system or any other thing so that they can view the earth. But nowadays the things have been changed a lot. We have the sophisticated satellite system that can measure the complete earth and give us the information about it. Okay, in GIS, when we talk about this geodesy topic, why we are learning about this particular topic in GIS? Because we need to measure the position on the Earth's surface. When we are saying that I am going to collect the spatial data, it is about measuring something on the Earth's surface. Okay, so when you are making that measurement, you need to learn about the shape, about the size, about other things, about the reference through which we are going to measure. That's why we are learning about this particular topic. So coming back to the geodesy, what is actually the shape and size? We have learned about the historical things, but actually what is the shape of the earth? So as it is given in the slide, this ellipsoid, which is also referred as spheroid, is much better approximation for the shape of the earth than the sphere, because if we see the earth's surface or the earth, the poles are flattened and the equator bulges out. Okay. So this was given by the Columbus, who has first said that earth is not a round figure, but it is somewhere like an orange. Okay, it is like an orange fruit that is a little bit flattened at the top position. So that's why the Earth is also like an orange, and it is flattened at the polar region and it bulges out at the equatorial region. So when we say something like that, it means that the Earth shape is not exactly symmetric. Therefore, it is not possible to estimate it by a sphere. It is estimated with the help of an ellipsoid. Okay. So the shape of the Earth is, it is like an ellipsoid, and when we measure it from north to south, that is from North Pole up to South Pole, the length is shorter, okay, the diameter is shorter, and when we measure from east to west, it means around the equator, the diameter is comparatively longer. Okay. So instead of saying this diameter, the term that we use over here is the axis, north to south or east to west. So there are two axes for the Earth. Okay. This particular figure is giving you a rough idea about the three-dimensional surface of the Earth. Okay. So if we talk about the surface of the Earth, there is a semi-minor axis. Okay. So this axis from pole 1 to pole 2, this is called the minor axis because the length is comparatively shorter from the east to west equatorial axis. Okay. So that's why this is called the minor axis, and half of the minor axis is semi-minor axis. When we move along the equator, it is the major axis because the length is longer, and half of that one is called the semi-major axis. Okay. So this is A, this is B. Then flattening. So we need to define flattening for the sphere. Flattening will be 0. Okay. So there will not at all be any flattening in case of the sphere. But when we talk about the ellipsoid, in case of the ellipsoid, there is a flattening. And for the Earth also, there is a flattening. The value of this f is given as a minus b upon a, where a is the semi-major axis and b is the semi-minor axis over here. Okay, so you need to draw this figure in your notebook. First draw this figure and then we will continue. So this is the mathematical model of the Earth. This is a mathematical model of the Earth, and we are defining the Earth shape and size with the help of some parameters. First one is the semi-major axis. Second one is the semi-minor axis. Okay, so there are total 6 parameters that are used to define the shape of the Earth. The semi-major axis is the equatorial radius, and it is defined as the half of the major axis. The semi-minor axis is the polar radius. So listen these terms carefully: polar radius and equatorial radius. The semi-minor axis is a polar radius and is defined as the half of the minor axis. So both these A and B, major and minor axis, have a very important role when we are defining the mathematical model, and usually the notation A and B is used for them. So then there is a flattening. If it is a sphere, then there will be no flattening. But when we are saying that the shape of the earth is like an ellipsoid, and then there will be a flattening over here, this flattening is given as F equal to A minus B upon A, which is written over here. So when we take this value of A and B and try to calculate the value of F, which is flattening, so flattening is very small value and comes up to many decimal places. So in GIS, in mathematics, the flattening results sometimes give problem because it is coming to in the decimal values. Therefore, in order to minimize the error and simplify the calculation and conveying the earth flattening information, there is another term called inverse flattening. Okay, another term called inverse flattening is used over here, and inverse flattening is nothing but 1 upon F. Are you getting this point? Why we are taking the inverse flattening? Because when we see the value of flattening, specifically for the earth, it is 1 upon 295. If you put the value of A and B and calculate it as A minus B upon A, the final value will come as 1 upon 295, and which means 0.003389831. So up to several decimal places it is coming. Therefore, it creates sometimes error while doing the calculation or conveying this information. Therefore, in order to minimize such type of error, inverse flattening term is used. So inverse flattening is nothing but 1 upon F. So the value of inverse flattening will be 1. It will be 295. F is 1 upon 295. So inverse flattening is 295. Then there are two more parameters, which are eccentricity and second in eccentricity. So this eccentricity and second eccentricity, they have to do more with the mathematical nature of the ellipsoid than its geographical use. But if we see the eccentricity value,
हेलो मैम.
yes,
मैम अभी आपने बोला इनवर्स फ्लैटनिंग 295, तो मैम ये किलोमीटर्स में है ना?
flattening will not be in kilometer. If you see the formula A minus B upon A, so A will be in kilometer, B in kilometer, and A upon A. So it is kilometer will cancel another kilometer. So there will be no, though there will be no unit for flattening.
Okay, ma'am. And what is oblate Earth? Because that figure, the 3-dimension oblate Earth. So, ma'am, yeah, here oblate means what?
You can see the difference in the shape. Okay, if you see this dashed figure over here, okay, so it is perfectly sphere, but there is not a perfect sphere. It is flattened down at the polar region. That's why this term oblate is used over here. 3-dimensional oblate Earth, oblate, because there is a flattening at the polar region. So to show this flattening, they are using this term oblate Earth. Okay. So we were discussing about the eccentricity. So the formula of eccentricity is, wait a minute. Yes, it is under root of a square minus b square upon a. The first eccentricity is under root of a square minus b square upon a. And second eccentricity, it is under root of a square minus b square upon b. Okay. So it is r upon a, r upon b, and the value of r is given as under root of a square minus b square. This is how the eccentricity value is computed. So eccentricity value can range from 0 to 1 for the circle. Okay. In case of circle, there is no flattening and the value of eccentricity will be 0. I hope everyone is writing the formula. You must have written the formula of flattening, inverse flattening, eccentricity, second eccentricity. Now what I am telling to you, if the shape is circle, then what will be the value of eccentricity? It will be 0, because value of E ranges from 0 to 1. For the circle it is 0, and for a straight line it is 1. It basically varies from 0 to 1, that is from circle to a flat line. So value for the ellipsoid will neither be 0 nor it will be 1. So it will have some very small value when you calculate the eccentricity of the Earth. So these are the total
Ma'am.
6. Yes.
Ma'am, in the earlier diagram which you showed, the Earth should be more bulged out at equator, na?
Yes.
But in the diagram it is given nearly equal.
Yes.
Exact.
So that is a slight bulge. You can see this dashed circle. Okay, it is not appearing over here. It means that this solid Earth means actual Earth, so-called actual Earth, is basically overlaying on that one. It is coming out from this dashed circle. You know, there is a very slight changes, small changes. So it will not appear like, there will not be a very significant difference between the bulging or the flattening at the pole. It will be a very small changes, small differences at this position. So that's why in this diagram you can see on the left hand side that no dashed circle is appearing on the left hand side. Okay, and even on the right hand side there is almost an overlap over here. Okay, so these are the total 6 parameters that are used to give the mathematical surface of the Earth. Now all the 6 parameters are clear. I hope you have written it down. Semi-major axis, semi-minor axis, flattening, inverse flattening, eccentricity, second eccentricity. So these are the total 6 parameters that are used to give the mathematical surface of the Earth. Okay, is it clear till now?
Yes, ma'am.
Okay. So now if you see what I am repeatedly saying, that this one is the mathematical surface of the Earth. If you see the real world, is the real world Earth is similar to this mathematical model because it is completely smooth. It is just only considering the flattening and the bulging, these terms only. But otherwise it is saying the surface of the Earth is completely smooth. Is it correct to say that the Earth's surface is smooth?
No.
ma'am.
Okay. So it is not correct, but still for the mathematical calculation purpose, we consider it as a smooth flat surface. Like if you go for different type of global measurements, you will find that they are considering the Earth as a smooth flat ellipsoid. How can you justify this assumption? Although you already know that Earth is not smooth, there are mountains, there are valley. It means that there is a depression, there is an bulging out. So how will you justify this thing?
By taking a datum or a reference point.
Okay, then if you
Ma'am,
take a
when we
date,
take mean level as a reference point, and then all the when all the surface of the Earth is converged into that level, then the higher elevated part are compared with the depressed part of the oceans. Then they get, if we take the mean of all those things, then they can be balanced.
you know, the MSL, the mean sea level thing that you are saying, then it is a different thing. It is not a mathematical surface. Okay. So the mean sea level is basically another thing that is used to take the vertical measurements on the Earth, and we are just coming on that topic. But the correct explanation that we
The
used to
crust of the layer is very thin, so it does not make any difference.
it basically makes the difference, but the difference is very small. You know, what is the highest point on the Earth?
Mariana Trench is 12 kilometer deep,
Highest
and
point.
Everest is
Mount Everest.
Yes.
Mount Everest.
Everest is 1.5
Mount Everest.
kilometer.
8850.
We consider the Mount Everest as the highest point on the Earth. And what is the deepest point?
Mariana Trench.
The Mariana Trench in the Pacific
Ocean.
So these are the two things, highest and the deepest. Now if you consider the height of the Mount Everest, approximate height, not the exact height.
8850 meters.
Okay, and what will be the depth of Mariana Trench? Approximate.
12 kilometers.
12 kilometers.
So this is what the basis is. If you see the Mount Everest, it is approximately, you see 9 kilometer, and the lowest point or the deepest point is the Marianas Trench. It is roughly 11 kilometer below the sea level. So if you do the summation, the total variation will come 9 plus 11, which will be 20. So total topographic height variation is 20 kilometer. And if you check the radius of the Earth, it is the shortest radius or the polar axis, polar semi-major, semi-minor axis is 6356. So the value of 20 is much less as compared to 6356 kilometer. So the height variation is there. There is no doubt about it. There is a topographic height variation on the Earth's surface. But if we compare that height variation, which is at most of 20 kilometer, then it is quite small as compared to the radius of the Earth. That's why when we are doing the mathematical modeling, in that case, we consider this difference as a negligible difference in the variation of height, and the smooth ellipsoidal surface is assumed for the Earth. So this is one of the explanation that can be given, that the total variation, I hope everybody is getting what I am asking, that here it is written that the mathematical surface of the Earth has been taken. Okay. So if when we say that there is a mathematical surface, it means it might be ellipsoid, spheroid, anything, whatever we are assuming, whatever is their parameters value, it's okay. But when we are saying it as an ellipsoid, it means that the surface of the Earth is smooth. The shape and size will vary, but the surface will be smooth. But if you see the real world, if you see the outside, it is not smooth. There is some point of high elevation, some point of depression. So this elevation and depression basically quite small as compared to the size of the Earth. That's why, assuming that this value is quite negligible in front of the size and size of the Earth, therefore for the mathematical calculation we go for the smoother surface. Next thing is about the mean sea level. Okay, MSL, mean sea level. So mean sea level for if you have seen the height, the elevation of any of the place, you may have seen this thing on the railway stations, that they have written down the height of that particular station. And what they say suppose 10 meter above the MSL. What they are talking about? They are talking about the mean sea level. If you haven't seen this thing,
yes, ma'am.
Check yes, this thing. Yeah. So check this thing next time if any one of you haven't seen this height information earlier. So whenever you will return to the institute or whenever you go to some of the railway station or anywhere else, check what is in which way they are writing down elevation of that station. So they must be giving it in terms of MSL or mean sea level. The height which is measured from the mean sea level is called the orthometric height. Write it down this term. Write down this term. Orthometric height is the height measured from the mean sea level, MSL. Okay, so in our day-to-day uses, the elevation are usually referred as the height above the or below the sea level, both. Okay, for example, if you consider the peak of the Mount Everest, it is approximately 9 kilometers above the sea level. Okay. If you see the base of the Marianas Trench, it is approximately 11 kilometers below the sea level. So Earth topography, as earlier I have told you, that the Earth topography varies up to 20 kilometers above and below the sea level. So the measurement that we usually take of any place is from the mean sea level, and the measurement is called the orthometric height. This orthometric height is
Ma'am,
measured with reference to the mean sea level. Yes.
ma'am, mean sea level is counted from continental shelf or from any other ground?
Sorry.
How is mean sea level counted? From continental shelf or any other way?
Yes, I'm coming to that one. So when we talk about the mean sea level, how that mean sea level is computed, as it is written over here, mean sea level at a location is obtained by averaging the height of the surface of the sea for all changes of the tide for a period of 18.6 years. So there are the different devices that are used for this purpose, and with the help of that, the level of the sea is measured, and it is not for 1 or 2 days, it is up to 18.6 years exactly that they used to measure the height of the sea surface, and on the basis of that they give the level of mean sea level. When we talk about the India, the mean sea level is computed at Mumbai port. So whatever is the reference surface, it is computed from the Mumbai port. Next, the question that you were asking, that from which place that the mean sea level is measured, it depends upon the different countries, the location from which that they are going to measure the mean sea level. This is important because the mean sea level is not global in nature. Okay, so it is defined in different countries. Like for India, as it is given in the slide, that it is measured at the Mumbai port. So mean sea level or MSL is not something that is global in nature. It is local. It is defined by the different for the country individually, or like for some of the countries which are very small. In that case, several countries together give a common mean sea level for their region. And the height can be both positive or negative. Okay. So as you can see in this particular diagram, the control station is measured from the mean sea level, and this height of the control station is called the orthometric height, and it is measured above the sea level. Now, there is another term called geoid. What is geoid? Now, geoid is an equipotential surface of the Earth gravity which coincides with the MSL. There can be several equipotential surface on the Earth gravity. Okay, there will not be a single equipotential surface. There can be several surfaces. But what we say, the equipotential surface that coincide with the MSL, okay, that one is taken as the geoid. Earlier, the problem that we were discussing in case of the mathematical model, that it gives us the smooth surface. But when we talk about the geoid, it will not give you a smooth surface. It will give you a very irregular shape, and the location where the gravitational pull of the Earth is stronger because of the area rich in the iron and other dense material. In that case, it will automatically fall below the geoid. Okay. So this, below the MSL. At most of the places, geoid coincide with the mean sea level, but it is not always possible. So if we see, diagram is not here, but yes, in this diagram you can see that these are the different type of surfaces. Okay, ellipsoid, geoid, and topography. So these are the three different surfaces that are given over here. Which surface is the real surface, or which surface do you see in the real world?
Topography.
Yes, obviously it is the topographical surface. Okay, the rest of the surfaces, ellipsoidal, geoidal, these all are the imaginary surfaces that are given for different types of calculation, mathematical calculation, positioning purpose. But if you go to the real world, what you will find? You will find the topographical surface. So what is the ellipsoidal surface? The mathematical surface, the smooth mathematical surface is called the ellipsoidal surface. What is the geoidal surface? The equipotential surface. Okay, listen this term carefully. The equipotential surface of the earth, which coincide with the MSL at most of the places, is called the geoidal surface. Okay. Then third one is the topographical surface. The real world surface that we see is called the topographical surface. Okay. Now based on this one, there will be a height, there can be orthometric height, there can be a geodetic height, and then there is another term called geoidal suppression. Now we will come all these terms, but there will be a 10-minute break because it is suggested to us that the lecture will be of 50 minutes. So there will be a 10 minutes break, and we will resume the class at 12 o'clock, and we will learn about all these three. Okay. So there is a 10 minutes break. let's start the class. So we were discussing about the geodesy, and in that we have seen the shape of the earth, and there was a lot of history behind the shape of it. How
Ma'am, voice
yes.
clear. Voice clear nahi ho.
Okay, is it clear now? Audio is not clear. I am getting it. Is it clear now?
Yes, ma'am.
Okay, if there is any problem in audio, then you can inform. I think so. The audio is clear to everyone.
Yes, ma'am, it's clear now.
You play the slides, then it starts breaking.
So the audio is getting big. Okay. Now.
No, ma'am, it's still breaking.
Okay. Okay, I have just unshare the screen, and now I'm checking is audio is okay now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. So I will continue for a while without screen share, and then I will share it again. Basically, we were discussing about the geodesy and other things. Yes.
Ma'am, if you upload the file,
Repeat.
Slide, and then
Yeah, it is already there. Yeah,
that
it is already there on MST.
the screen, and that is why it is taking too much amount of internet data. But if you upload the file and that directly that from into the MS Teams slides here, then it will take less data.
Okay, then let me try. You are saying that I will open the PDF. I will open the PowerPoint presentation on MS Team, is it? And then share my screen. This is what you are suggesting?
Yes, ma'am, but then you don't need to share your screen. It will automatically be shown.
How to do this thing? And what you are saying that, yeah, okay.
Ma'am, if it is a problem of audio at your end, it's better you open your
PDF file at your end, and we all will open in the Teams because it is already uploaded Geodesy PDF.
Yeah, it is uploaded, but it will. There is one suggestion given by the student. So let's try with that one. And if the problem persists, then we will try for your solution also.
Okay.
Ma'am, I think so that is not possible in this way, ma'am. Actually, it is taking only PowerPoint files. It is not accepting the PDF files.
Okay. So I will see your suggestion later on. So let's continue the class. So now the audio is okay. Sometimes there is an internet problem for a while, for few minutes, and later on it will get corrected. I hope so the audio video is everything is now okay.
Yes, ma'am.
Yes, ma'am.
So we were discussing about this geodesy, and we have seen the mathematical surface of the earth. In that we have learned 6 different parameters that are used to define the shape of the earth. So those parameters were semi-major axis, semi-minor axis, flattening, inverse flattening, eccentricity, and second eccentricity. After that, we have started to give some other things. First one was the mean sea level. Okay, so mean sea level is the average sea level, and which is measured over the period of 18.6 years, and it is a local measurement. Then there is a geoidal surface. What is geoidal surface? It is an equipotential surface that coincide with the mean sea level. After that, we are now going to see the different type of height measurement. If you see the measurement of height, or if you see the relationship between the ellipsoidal surface, geoidal surface, and topographical surface. Okay. So as you can see,
Ma'am, geoidal surface is different for different countries since mean level is different.
yeah. So as you can see over here, there is a capital H. Okay, capital H is the height measured from the geoidal surface up to topographical surface, and geoidal surface is coincide with the mean sea level. That's why this height will be known as, you have already written the name of this height as orthometric height, isn't it? Orthometric height is the height measured from the mean sea level. So here also the capital H is the height measured from the geoidal surface up to the topographical surface. So whatever object is present at this particular circle, the height, this capital H height is called the orthometric height. Now second height is the height which is measured from the ellipsoidal surface of the earth, the mathematical surface of the earth. This is the small h, and this height which is measured from the ellipsoidal surface is called the geodetic height. Write down the name of this height. This is a very fundamental question. Even during the interviews also, students are not able to answer this question. What is the orthometric height and what is the geodetic height? This is a very fundamental question. Why? Because when you use the GPS, you need to measure the elevation. So many times there is a question, which type of height do you measure from the GPS? And students are blank on this question. So that's why remember the name of these height. What is geodetic height The height that is measured from the ellipsoidal surface is called the geodetic height. The height that is measured from geoid or mean sea level is called the orthometric height. And the relationship is geodetic height is equal to orthometric height plus geoidal suppression. In some book you will find this term as geoidal undulation. You know, it is not
sometimes we are measuring orthometric height from geoid and sometimes we are measuring orthometric height from sea level.
Yes, because geoidal surfaces, geoid coincide with the mean sea level. Okay, since geoid coincide with the mean sea level as it was earlier said, therefore whether you are measuring it from the mean sea level or whether you are measuring from the geoid, it is known as the orthometric height at most of the places, not all the places, because at few of the places there is a difference between the geoid and the mean sea level at some places. Therefore, at those places this may not be correct, but for the general terms we say this whether it is measured from geoid or whether it is measured from the mean sea level, in both the cases it is called the orthometric height. Okay, so the geodetic height which is measured from the ellipsoid is equal to mean sea level height plus geoidal undulation or geoidal suppression. Now what is geoidal suppression? The gap between the ellipsoid and geoid. Okay, you can see in the figure capital N over here. Okay, so this capital N is the separation between the geoid and the ellipsoid. This separation is called the geoid separation or geoid undulation. So this is not always positive. Sometimes geoid goes below the ellipsoid also at the places that are rich in this iron and other dense material. In that case, this N can be negative. Okay, so again remember this thing that the geoidal separation at most of the places it is positive, it is above the ellipsoid, but at some of the places it is possible that geoid will be negative. At several places in United States, it is negative. It is below the ellipsoid. So these are the two basic height that you need to remember, geodetic height and the orthometric height. One is measured from the ellipsoid and another one is measured from the geoid or the MSL. This is what the relationship between the geoid, ellipsoid and the topography. Now we are moving for the next topic, and this next topic is about the datum. Okay, what is datum? Again, this is a very fundamental question. These few things are very fundamental, and students are, I do not know why they are not able to answer this question. Even our own students are not able to answer this question later on. So that's why I'm telling you all to remember these things very clearly, because these are like a basic building blocks. They are a very basic fundamental questions related to GIS, and these are not just restricted to GIS. You will find their application in GPS also later on. Okay, so therefore remember these things, whatever I am telling you the important, remember these things so that you will be able to answer these basic things, because if you do not know about the height, about the datums and other things, they will ask you what you have learned in GIS. Okay, you may not be able to answer some of the GIS analysis, it may be okay, but if you will not be able to answer these fundamental questions, then it's not okay. Therefore remember these things. So datum, you may remember that when we were studying about the topo sheets, at that place also there was a datum. So what was the datum in that topo sheet, Survey of India topo sheet?
WGS 84.
Yes, and what was the projection system? It was UTM. Okay, so the Survey of India topo sheets that in which you were working, it has the datum of WGS 84 and reference the projection system of UTM. So projection system will be covered later after 2-3 lecture, but right now we are discussing about the datum. Okay. So first thing is, what is datum? Datum basically means the reference against which we are making the measurements. Okay, specifically when we talk about the GIS, so what is datum over here? Datum is something against which we are making the measurement. Okay, so there can be a vertical datum, there can be a horizontal datum, because we are measuring. When you take a measurement of any spatial data, there are three components: X, Y, and Z. So X and Y is measured in the horizontal surface, Y is measured in the vertical surface. So that's why we need two types of datum: vertical datum and the horizontal datum. With the help of both these datum, we need to measure the location of any object. And why they are so important? Because they, if you follow some news and other things, you may have heard that US is using their missile. They have locked their target and they are using the missile attack and other things. So when we hear such type of news, when they say they are locking their target at some enemy place, like they were doing a lot of missile attack in Iraq and Israel, Iraq and this Afghanistan, not Israel. So when they are doing such type of attack, it is very important to lock the target, position very carefully, because many times when they have a target at the heart of the city, then there will be some schools, there will be some religious places, there will be settlement, people are living at that place. So target cannot be a children, or there cannot be a common citizen of that place. So they need to target at the terrorist only, not at some religious place or school or library and other things. In that case, the accuracy of missile had to be extremely precise, so that only the target will get destroyed and the surrounding innocent people will not get killed. In this case, using the exact position is possible with the help of this all information, with the help of the ellipsoid, with the help of this datum and other things. In all these things, GPS based targeting systems are used. Okay, so it is another thing. But when we talk about the GIS also, here also we are doing the measurement. Okay, so the standard ellipsoid provide enough accuracy and provides sufficient accuracy for small and large scale GIS application. But when we go for the military missile system and other type of things that involve the collateral damage, in that case, the degree of precision, the degree of positional accuracy is needed. Okay. So here also, we need to learn about the datum. And when we examine about the datum, there are two things: vertical datum, which is used to define the vertical position Z with respect to a reference surface, and we need to define the horizontal position in terms of X and Y. Okay. First thing is about the vertical datum. We have already collected some of the knowledge with the help of this height measurement, geodetic height and orthometric height. So this is somewhat repetition of that information. When we say about the vertical datum, I'm just reading it out. A vertical datum is a reference surface used to measure elevation of the point on Earth's surface. It is tidal based on sea level or geodetic based on ellipsoid. So first, there are two types of vertical datum. Write down in a copy. Okay, basically make a diagram, write down datum, make a classification of the datum. Okay, write down datum and bring two arrow from the datum. Vertical datum on left and horizontal datum on the right. Are you getting this? what you need to do, you need to write down datum, then vertical datum, then horizontal datum. Inside the vertical datum, there is a tidal datum, and another one is geodetic datum. Make a diagram like this so that you will remember the classification of the datum. So which height will be measured by the tidal datum? It will be the orthometric height. Okay. Which type of height will be measured by the geodetic data? It will be geodetic height or ellipsoidal height. Which type of datum will be used in GPS? Now this one is the interesting question.
Geodetic.
Horizontal datum.
If you are measuring the vertical height from the GPS, which type of data will you use?
Topographical.
Geodetic.
There are only two types of datum, tidal datum and geodetic datum. There is no topographic datum.
Geodetic. No.
Anyone with the
Ma'am,
tidal?
geodetic.
Okay, most of you are saying geodetic. Anyone with the tidal? Yes, so the answer was correct, geodetic data. You know, as I have told you earlier, that the tidal datum, coming to this one, yes, tidal vertical data makes local mean sea level as reference for height measurement. MSL is defined as zero elevation for local area and its close approximation to the geoid. As zero elevation defined for one country is not necessarily same for other countries, therefore a number of local vertical datums are defined. Second one is the geodetic vertical datum. It uses ellipsoid as the reference surface. The surface of the ellipsoid is considered to represent zero altitude. The measured altitude is known as the ellipsoidal or geodetic height. GPS device furnishes ellipsoidal heights. When you see, I was giving you the example of railway station. So it is one of the height which is used for a local purpose for the citizen of India. So in most of such places you will find that the height is measured with respect of mean sea level. So as it is mentioned over here again, that it is not uniform for all the countries, it varies from country to country. In most of the time, the mean sea level or the tidal vertical datum is used when it is used for some country or for some local purpose. But whenever our application is global, in that case, we cannot go for the tidal vertical datum because it is not valid for the whole globe. For that case, we need to go for the geodetic vertical datum because it uses the ellipsoid as the reference surface. And therefore, the GPS device measures the ellipsoidal height or the geodetic height. If you measure the XYZ position corresponding to any height, the elevation, the height, the altitude will be measured from the ellipsoid, and it will give you the geodetic height. Coming to the next one, it is the horizontal datum. Now the horizontal datum, again go back to that diagram. It will be again of two types. It is geocentric and second one is non-centric. So a horizontal datum is defined as an ellipsoid which is used as a reference surface for the planimetric measurements on the Earth's surface and usually expressed in latitude and longitude. It can be of two types, geocentric and non-geocentric. What is geocentric datum? Geocentric datum, which is also known as the global datum. So as the name suggests, okay, if you see the name geocentric, the origin of this datum. If you see the XY, the origin of XY axis will lie at the center of the Earth. The Z axis will align with the spin axis of the Earth. The center of this spheroid coincide with the center of mass of the Earth. Such type of datum is called the geocentric datum. Geocentric datum again is used for the global measurement. That's why GPS used the geocentric datum. Write down this thing in your copy that GPS uses the geocentric datum for horizontal measurement and geodetic datum for vertical measurement. Okay. Another term is the non-geocentric system. And when we go for the local observations, in that case there is a non-geocentric systems. Like in India, the open series map are quite new map. It comes after the new mapping policy, and they have started to use the WGS 84 as the reference datum. But earlier to that, if you open the old maps, you will find that they are based on the Everest datum. So in India, Indian Everest system was used by the Survey of India, and our earlier topographic mapping is based on this particular local geodetic system. Write down this point is important, that the origin of Indian Everest system was at Kalyanpur, Madhya Pradesh. So when we talk about the horizontal datum, the non-geocentric systems or non-geocentric datum are the local datum. In this case, the origin will lie at some place on the Earth's surface. In geocentric datum, the global datum, the origin will lie at the center of mass of the Earth. But in case of non-geocentric and most of the local mapping, we use the Indian Everest system. Nowadays, everything is going towards the global thing, and that's why WGS 84 is used for that one. Now there is, for the horizontal datum, this WGS 84 is very popular. What is the full form of WGS 84? It is World Geodetic System. Write down the full form of WGS 84. World Geodetic System 1984. Because you will listen this WGS 84 all the time throughout the MTech, throughout most of the subject, every time there is WGS 84, somewhere during the laboratory session, somewhere during the theory session. So first thing is, what is the full form of WGS 84? It is World Geodetic System 1984. And it is considered as a global datum that defines an Earth fixed global reference frame for the Earth. Okay. You will learn in some of the subject ECEF, Earth Centered, Earth Fixed. I'm not going into that particular topic, but this ECEF is used, this Earth Fixed Global Reference System is used by the WGS 84. So the WGS 84 is based upon the ellipsoidal parameters of Geodetic Reference System of the year 1980. And this WGS 84 is used for GPS satellites also. And the very first time when this WGS geocentric datum appeared was in the year 1960. Okay, in the year 1960, it was basically the product of United States Defense Mapping Agency, DMA. Okay. So whose product was WGS? Another question. The answer is United States Defense Mapping Agency. In the year 1960, this WGS 60 was given by the United States Defense Mapping Agency for mapping and charting purpose. Okay. So initially, it was evolved from the primitive satellite measurements, and over the time, it evolved into the WGS 84, and it uses satellite-driven precision, and it provides a very satisfactory reference datum for nearly every Earth location. WGS 84, that's why, is very popular, and I will show you one thing, how the datums are defined. So I have just opened the ArcGIS software, the Arc Catalog component of that one. On the screen right now, you can see I have opened the this XY coordinate system of the shapefile. Okay. The screen is visible to everyone?
Yes, sir.
Yes, ma'am.
Okay. So here you can see the XY coordinate system, which is horizontal datum is given over here, and you can see the name is GCS WGS 1984. Okay. Geographic coordinate system, World Geodetic System 1984. Now in this particular, you can see the details, what details that they are giving. They are giving angular unit degree. Okay. They are giving the position of prime meridian as this. Datum name is WD_WGS 1984, spheroid is WGS 1984, and then they are giving the three main values. The value of semi-major axis, the value of semi-minor axis, and inverse flattening. So these are the three terms that are used to give the reference ellipsoid against which all the measurements are made. So whenever you select any of the reference system, you will find such type of thing. Like I will show you one thing. Earlier I was telling you that India uses the Everest datum. There is, I think so, a little bit lag in the screen. Just wait for a minute. I don't know whether the coordinate system Everest, India, and Nepal is coming on your screen or not. I will wait for a while, it will appear. So basically, I am selecting the coordinate system, and as you can see over here, I have gone to geographic coordinate system and then to the Asia, and inside the Asia there is Everest India Nepal.prj. So this Everest India Nepal is the datum which was earlier used by the Survey of India. Okay. Now you can see, once I have selected the Everest India Nepal, you can see that the value of semi-major axis, minor axis, and especially in inverse flattening, you can see that earlier the inverse flattening was 298 point something for WGS 1984. But when I am selecting this GCS Everest India Nepal, the value are getting changed. Okay, so this is what the datum is. When you define any datum, it basically gives the mathematical parameters of the Earth's surface that we have earlier learned. Okay, earlier we have learned about the 6 different parameters over there. So as you can see over here, that all the parameters that are relevant for defining the Earth's surface mathematically, it is given by the datum. And there is no single datum, there are so many datums. Okay. Now if I open this, just wait for a minute, it will appear on the screen. I have opened the geographic coordinate system, and inside this geographic coordinate system you can find there are so many coordinate systems inside different continents: Africa, Antarctica, Asia, Atlantic Ocean, Australia and New Zealand, Caribbean, County System, Europe, Indian Ocean, North America, Pacific Ocean, Solar System, South America, spheroidal based world. So these are the so many options where you can find the geographic coordinate system. And when I go inside the world you can find the WGS 1984. This is the world coordinate system. It is used for the geocentric coordinate system that is used for the global purpose. There is one more name over here. Apart from WGS series, there is another name, ITRF. Isn't it? ITRF. Now, another major global reference is named as ITRF, and the full form of ITRF is, write down in your copy, the full form of ITRF, International Terrestrial Reference Frame. International Terrestrial Reference Frame, ITRF. International Terrestrial Reference Frame. So this reference frame is used for large selection of astronomical, geophysical and geodetic analysis, and its products are popular around the world, but they are more popular in European region. So the goal of this particular geodetic datum, ITRF, is the realization of terrestrial coordinate system through the creation and implementation of terrestrial reference system. So remember this full form, ITRF, International Terrestrial Reference System. Then there is another system called North American Datums. I have opened the North America. So here you can see this NAD 1927, 990, NAD 1920, 1983 and others. So NAD stands for North American Datum. So the North American datums of the year 1927 and 1983, these were established to provide accurate positional coordinates and increased horizontal control for any location within the North America. So this is the popular one, North American Datum, NAD. There are two versions, 1927 and 1983. Similarly, for the Europe, you can also find there is a European datum. So there are hundreds of datum. As you can see over here also, whichever continent I am opening or whichever region I am opening, there are several datum inside it. But I'm just mentioning few of them which are quite popular. So you have seen, apart from WGS 84, you have seen this ITRF, then North American datum NAD. There is another popular one, European datum. Okay. So this European datum during World War II, the accuracy and compatibility of latitude and longitude in the Western Europe is a big issue. And when they are fighting the war at the border of Germany, France, Belgium, Netherlands, they have proved that the datum inconsistencies existed, and there was a lot of problem at that time during the World War II, because at that time also they were using their several war weapon at that time that were creating the problem. Therefore, this European datum 1950 was created at that time, and later on this has been modified and become popular along the whole region. Okay. So as you can see, there are several version. European datum 1950, European datum 1987, both are available at this time. So this is about the geodetic datums. Now there is one thing at your side that you need to do. You need to learn more about the Everest Indian system. Although very brief detail is given over here, but since this one is the datum of India and it was used by the Survey of India for the earlier surveying, so you must need to learn about it. So go to the internet, okay? Later on, go to the internet and learn about this particular datum. Everest, India, Nepal, this particular datum which is used by the Survey of India. Now I'm moving to the next topic, although we have very less time right now. So a part of it will be covered today and rest of it will be covered on Friday. This is about the latitude and longitude. How many of you will define latitude and longitude as the horizontal, latitude as the horizontal line and longitude as a vertical line? Okay. How many of you, suppose if somebody asks you what is latitude and longitude, how many of you will say that the longitude is the imaginary vertical lines that are drawn on the surface of the earth, and latitudes are the imaginary horizontal lines that are drawn on the surface of earth? How many of you will define lat long in this way? Okay, there's no need to answer it because nobody is going to answer this question. But I think so all of you know that what answer will you give when somebody asks you to define the latitude and longitude. As a GIS person, you cannot define this thing in such a layman language. Okay. Because again, we have seen that during the Viva session, even after 6 months, student used to give latitude and longitude as the horizontal and vertical lines that are drawn on the Earth's surface. This is not a definition of latitude and longitude. Okay, this is not at all the definition of latitude and longitude which will be given by any GIS student or GIS professional. Now, how we are going to define this latitude and longitude thing? This is important and you need to remember, although it appears a little bit complicated right now, but over the time, when you mug up these definitions, you will understand it, and it is quite easy if you try to visualize this thing in your mind. Okay. First, I'm going to the longitude. Longitude, the notation of the longitude is lambda. Write down in your copy. In your copy, write down the longitude notation is lambda, as it is given in the heading longitude. Inside the parenthesis there is lambda. Okay. So yes, line of longitude starts from one pole, radiate outwards, and until they converge at the opposite pole. They are the vertical lines that are drawn on the Earth's surface. There is no doubt about it. These all are the imaginary line. Okay. And if you try to imagine it, just try to think about the orange fruit. संतरे को सोचिए. Okay. So how will you visualize an orange? Okay. सबने संतरा खाया है? If you try to take out the slice of the orange, okay, the way you slice out the orange, it is the longitude. एक एक फांक संतरे के फल की हम जैसे निकालते हैं, वह एक हम लॉन्गिट्यूड को निकालने जैसा है. पहले थोड़ा संतरे के फल को याद करिए, क्योंकि बहुत दिन हो गए होंगे खाए हुए. उसके शेप को सोचिए, उसको थोड़ा सोचिए किस तरीके से आप एक स्लाइस उसकी निकालते हैं. मैं कैसे नॉर्मली कोई बीच से काट करके उसको निचोड़ता नहीं है. जैसे नींबू को हम लोग बीच से कट करके स्लाइस आउट करके बीच से कट करके हॉरिजॉन्टली हम उसको जूस आउट करते हैं, लेकिन ऑरेंज को हम कैसे करते हैं? फर्स्ट ऑफ ऑल हम उसका स्किन जो होता है, उसका जो छिलका होता है, उसको स्किन आउट करते हैं एंड देन उसकी स्लाइसेस हम इंडिविजुअली निकालते हैं. जस्ट ट्राई टू थिंक द वे यू स्लाइस द ऑरेंज इज लाइक अ लॉन्गिट्यूड. ओके, it goes from one pole to another pole. It's okay. The exact definition of the longitude that you need to give in any of the interview or in any of the viva session is the third one. The longitude of a point is a horizontal angle measured in the plane of equator between the plane of the meridian through the point and the plane of prime meridian. Okay. Write down this definition in your copy and then we will discuss what is mean by this definition. Just try to think about this definition, even if you are getting confused with this one. But you must remember this definition is what you need to give when somebody asks you about the longitude. Because earlier when we were doing the geo-referencing, the latitude and longitude was given in terms of angle, isn't it? The longitude was 81 degree 25 minute, 81 degree 15 minutes, something like that. So longitude is basically an angle. And whenever we say anything angle, then that angle need to be measured, and that will be measured between two planes, between one plane and one line, or between two lines. This is something about basic geometry, isn't it? How do we measure an angle? So for the measurement of angle, the angle will appear only between two planes, between one plane and one line, or between two lines. Okay. Here also, when we are saying that the longitude is the angle, then there will be two planes. What is the name of these two planes? One is the plane of prime meridian. Another is the plane of meridian, which is passing through that particular point of concern. And where is that angle is measured? In the horizontal plane of equator. Write down the definition and I am going to discuss about that afterwards. Okay, so you can see it over here that when we talk about the longitude, this longitude is measured between two planes. You can see this diagram that the longitude is measured between two planes. One place is the plane of prime meridian. What is prime meridian? Prime meridian is one of the standard meridian, although it can be taken anywhere. It is an arbitrary meridian, but in most of the places, the meridian or the longitude, meridian and longitude both are the same things. So the meridian that passes through Greenwich, England, through the Royal Observatory of Greenwich, England, that particular line or that particular meridian is called the prime meridian. So whenever you are making any measurement, earlier we have learned all this datum, we have learned about the mean sea level, about the geoid, about the ellipsoid. Whenever you are measuring the height, you need some reference surface, isn't it? For the measurement of longitude also, we need some reference surface. What is the reference surface or what is the reference plane for this purpose? It is the prime meridian. What is prime meridian? Prime meridian is one of the arbitrary meridian which is taken as a reference, and for most of the cases, the meridian that passes through Royal Observatory in Greenwich, England is taken as the prime meridian. Okay. This is one thing. Now coming to the next surface. So one surface is of prime meridian. Second surface, okay, so like as you can see in this particular diagram, that we are measuring the coordinate of this particular point where the arrow is pointing. Okay, so there will be one more meridian, one more longitudinal plane which is passing through that place, isn't it? As you can see in the on the screen also, this one is another plane. So there will be two planes. One plane is of prime meridian, another plane is the plane which is passing through that particular point, the meridian plane which is passing through that particular point. Now we need to measure the angle between these two planes. Where it is measured, because the angle is not uniform at all the places, because these lines are not parallel. It is getting converged at the polar region and they are at the maximum separation at the equatorial plane. Therefore, we will measure it in the plane of equator. And it is the horizontal angle. As you can see in this figure, 60 degree, 0 minute, 0 second. So this 60 degree is measured in the plane of equator and it is the horizontal angle between these two planes. This is what the longitude is. So I am repeating the definition which you have learnt earlier or written in your copy, that the longitude is the angle measured between the plane of prime meridian and the plane of meridian passing through that point in the plane of equator. Get it? Now coming to the second, latitude. What is the latitude? Again, you can see on the screen. Try to think about the definition of latitude by yourself, because I have not given you the definition of latitude. But since you have covered the longitude, you have seen the description of latitude. Longitude. You have seen the description of longitude. Try to define the latitude. The angle and the other things are given on the screen. The latitude is 53 degrees, 60 minutes, 0 second. So now this time there is one plane and one line. What is the plane? The plane is of equator and the line is the radial line drawn from the center of Earth towards that point. This is called the latitude. So latitude is the vertical angle. Listen these terms carefully. Earlier for the longitude I was saying it was the horizontal angle. Here I am saying it is the vertical angle measured between the plane of equator and the line drawn radially outward towards that point. This is what the latitude is. Here the reference surface is the equatorial surface. Okay, so ये दोनों definition है latitude और longitude की. ध्यान में रखिएगा सरफेस कौन सा यूज हो रहा है. लॉन्गिट्यूड के केस में दो प्लेन को यूज किया जा रहा है. एक प्राइम मेरिडियन का प्लेन है और दूसरा प्लेन उस पॉइंट से पास होने वाला मेरिडियन प्लेन है. इन दोनों प्लेन के बीच में लिया जाने वाला हॉरिजॉन्टल एंगल है. वो हॉरिजॉन्टल एंगल कहाँ पर मेजर हो रहा है? वो इक्वेटोरियल प्लेन में मेजर हो रहा है. ये स्पेसिफाई करना क्यों जरूरी है? ये स्पेसिफाई करना इसलिए जरूरी है क्योंकि लॉन्गिट्यूड जो है वो पैरेलल नहीं है. लॉन्गिट्यूड की लाइन को अगर आप देखें तो वो पोलर रीजन पे कन्वर्ज हो रही है और इक्वेटोरियल रीजन पे उस पर बहुत ज्यादा गैप आ रहा है. इस कारण से जब हम लोग लॉन्गिट्यूड का डेफिनेशन देते हैं तो लॉन्गिट्यूड एक हॉरिजॉन्टल एंगल है जो प्लेन ऑफ प्राइम मेरिडियन और प्लेन ऑफ मेरिडियन जो पॉइंट के थ्रू पास होता है उनके बीच में इक्वेटोरियल प्लेन में हॉरिजॉन्टली मेजर किया जाता है. वहीं जब हम लोग लैटिट्यूड की बात करते हैं तो लैटिट्यूड एक प्लेन और एक लाइन के बीच में नापा जाता है. वो प्लेन कौन सा होता है? वो प्लेन होता है इक्वेटोरियल प्लेन. और वो लाइन कौन सी होती है? अर्थ के सेंटर से, ठीक है, अर्थ के सेंटर से उस पॉइंट को मिलाने वाली जो लाइन होती है उसको कंसीडर करते हैं. तो ये एक वर्टिकल एंगल होता है जो एंटी क्लॉकवाइज डायरेक्शन में मेजर होता है बिटवीन द प्लेन ऑफ इक्वेटर और लाइन जो कि रेडियली आउटवर्ड जाती है उस पर्टिकुलर पॉइंट की ओर. दिस इज व्हाट द लैटिट्यूड एंड लॉन्गिट्यूड इज. ठीक है, लैटिट्यूड का डेफिनेशन अभी लिख लीजिए और लैटिट्यूड का और डिस्कशन हम लोग अगले टर्न पर करेंगे क्योंकि टाइम ओवर हो रहा है. सो लैटिट्यूड का जो सिंबल होता है, नोटेशन होता है, वो फाई का सिंबल होता है और डेफिनेशन यहाँ पर लिखी हुई है, इसको नोट डाउन कर लीजिए अपने नोटबुक में. द latitude of a point is a vertical angle measured at the center of the earth between the plane of the equator and the radius drawn to the point. Write down the third point of this slide. This is the definition of latitude. That's it from my side for today. In this term, we have learnt about the geodesy, datum. Both are the very important concept. We have started the discussion of latitude and longitude, and it will continue in the next term. And we will start the topic of map in the next turn also, so that we will know you will know the concept of spatial entities, scale, generalization, and other thing. It will be a long topic. On the Friday session, we also have the tutorial session and the map, the Survey of India topo sheet of the Prayagraj district is already there. And I hope all of you have downloaded the maps that are given over there. So before coming to the tutorial session, what you need to do, you need to perform the georeferencing of all the maps. Okay, so that we can discuss more things about the extraction, about the merging, clipping, and other things of that map in the next time. So that's it from my side for today. Thank you so much, and we will continue this topic and the tutorial session in the next time. The class is over.
Excuse me, ma'am.
Thank you, ma'am.
Yes, there is one question.
Ma'am, last time you were saying that ask me how to save that geo-referenced file.
Please ask the question again.
Ma'am, that how to save the geo-referenced file that we do geo-referencing part, and in what form we save it?
No, I was not able to recall, but yes, there was some question that was asked to you earlier, and I have told you that you have a class from 4 o'clock and you need to ask that question again on Wednesday.
Yes, ma'am.
Yeah, please repeat the question.
Ma'am, that how to save the geo-referenced file that we do geo-referencing, then at last how to save it?
Yes, so I have told you to go to the transformation settings, and when you go to the transformation setting, there is an output window over there, and you need to give the name at that place.
Ma'am, if we don't give the particular name, then where does it say by itself?
No, I don't think so. It will execute if you do not give the output location.
It will ask the output directly.
Yeah, there will be some location where you need to save, whether you give it at that place or maybe later on there will be some window that will ask you about the location of the output.
Okay, ma'am.
But it's better instead of doing this type of thing, it's always better if, although in my system I never face such problem because it is taking by default some location. Okay, usually the original file where the ungeoreferenced sheet is there, at the same place the georeferenced file gets saved. Like suppose you have placed it inside a C drive, there is a GIS folder. Inside that GIS folder there is ungeoreferenced topo sheet. Okay, and in my system, I do not know about your system, but in my system, automatically, if I do not give anything, it will automatically save the georeference sheet inside the C drive GIS folder.
Ma'am, there is file name that which we get after the name we get modified term.
Yeah.
Is that the same?
Yes, the modified. If you do not give the name, although it is always suggested to give a proper name to the georeference sheet, otherwise it will get very confusing. But by default, the software automatically, suppose it is 63G, so the output will come 63G underscore modified, like this.
Hello, ma'am.
Yes.
Ma'am, do we have to write GCP tables for all?
No need to write the GCP tables, but yes, make sure that the residual error is less. Because this is a tutorial session and there are several maps over there, therefore I am not suggesting you to write down the this GCP table, but yes, make sure that you are doing the georeferencing process correctly. Otherwise, later on when we do the merging of all the topo sheet, so that you will get a single base map of the complete study area, then it will not get merged properly. Any other question?
Ma'am, the last tutorial part which you had given all the math to, we have to write it in separate file also, is that?
Yeah, later on. Right now you do not need to write anything, but once this tutorial topic is completed, it means the extraction of the district boundary and block boundary and other things. After that, I will give you the tutorial and then you will have to write. Right now, for the tutorial session, you do not need to write anything.
Thank you.